Hello, Cappuccino. It looks like you might need some help on page 521, problem number 4, okay, from the textbook. I've gotten some email requests and I've also looked at some work that's been turned in. And first of all, if you just copy the answer out of the back of the book, I'm giving you a big 0. All right, you need to do this just like the notes. So what did the guy do in the notes? He set up a table and he set up a graph, and then he substituted in values from the table into the equation so that he could find the slope and put them on the graph. So that's what you need to do. You need to do exactly what the guy did in the video. So our equation that was given is they give us dt over d lowercase t. So this is, t is the size of a tumor and lowercase t is time. So this is the rate of change of the size of the tumor. And it's equal to the opposite of the size of the tumor times the natural log of the size of the tumor divided by 2. Okay, so there's the equation they gave us. So then we would set up a table. So our x value, if we were setting up an xy and then dy dx, this is going to be our x value is the t. So we're going to have t is going to be the first part of our table, and then capital T, so time and size of the tumor, and then the derivative, so dt dt. Hate it when they use the same letter over and over again. All right, now the other thing the guy did in the video is he set up his graph. He set up his graph. So now they gave us more information in the problem. They said that lowercase t is going to be between 0 and 6 seconds. So seconds? No, I don't even remember. Probably not seconds. We're talking about the growth of a tumor. It's not going to grow that fast. Well, anyway, regardless, whatever the units was, it was between 0 and 6. Okay, and then for the size of the tumor, they wanted us to go 0 and 3. Okay, so that means I need to find slopes for all the points that fall into this area right here. So I want a slope for 1 and 1. I want a slope for 2 and 1. I want a slope for 3 and 1, 4 and 1, 5 and 1, 6 and 1. And then I want, 0 and 1. Okay, so you're going to plug in numbers here that correspond to these points. We could also do 0, 0. Okay, so I'm going to put 0 for lowercase t and 0 for uppercase t. And now I'm going to substitute these into the formula to get my rate of change, to get my slope. Okay, so if I plug this in here, notice there is no lowercase t. So don't worry about it. Don't plug it in. It doesn't matter. So if I plug it in, dt dt is equal to negative 0 times natural log of 0 over 2. And then if you put that into your calculator, where's my calculator? I'm guessing it's going to say undefined, but let's just go ahead and do it. So negative 0, which is just 0, right? So I'm going to do 0 times natural log of 0 divided by 2, just to do it. What the heck? Let's see what it says. Error domain, okay? It's undefined because you cannot take the natural log of 0. 0 divided by 2 is 0, and there is no such thing as the natural log of 0, because that would be asking e to the what is equal to 0. That's impossible, okay? Can't do it. So that means that it's undefined. So our slope is undefined at 0, 0. It's undefined. What does an undefined slope look like? It's vertical. It's going to be a little vertical line, okay? It's vertical. So at 0, 0, I'm going to have, maybe I'll use a different color. That's a good idea. I'm going to have a little tiny segment that is vertical because it has an undefined slope. All right. Then let's say I want to do 1, 1. I could do this point. Okay, I could put in 1, 1. And again, I would substitute it in. So my dt is equal to negative 1 times natural log of 1 over 2. You're going to put that into your calculator. You're going to get your result right here. You're going to write it in the table. And then you're going to make a little sketch right here where that little point is. You're going to make a little tiny segment that has the same slope that you found here, or approximately the same. So if you're going to get decimals because you're doing it on your calculator. So just think about, is it close to 1? Is it close to a half? And what would that look like? Okay, so think about your slopes. You know, are they steep? Are they really steep? Are they not so steep? And then go for it. So I expect to see a bunch of points on here. Pick a bunch of points. I expect to see them in your table. I expect to see a bunch of derivatives over here, just like the guy did in the video, except remember he paused the video to do all the work. I want to see your work. I expect to see your work. All right. And if you have some shortcut that you're using, you need to explain to me what your shortcut is, because if you're not showing work, to me, you're not doing nothing. All right. So that's it. Good luck. And how do I stop this video?